Hello everyone, we are Group 7 from Section 1 of our separation process lecture, and this is our service learning video on distillation. Have you ever wondered how crude oil becomes fuel or how we get clean water from the sea? Ladies and gentlemen, let us introduce you to the magic of distillation. This is our team for today with Arivarusu, Wenjian, Jiwa, Nilesh, myself and Sudan.
Before we move on to the distillation part, let us have some core understanding on the distillations. That is vapor liquid equilibrium VLE. So what is VLE? Now, the most simple illustrations of VLE is actually the water boiling process. Now, imagine you are going to make a cup of coffee, so you need to boil the water. We are going to put a piece of glass plate on top of the open boiling water. The hot steam evaporated from the boiling water will then touch the cold surface of the glass plate. This phenomenon will force the hot steams to condense, and the condensate will fall back through the boiling water. Imagine that the hot water keep boiling and evaporates to touch the cold surface, and it condenses and fall back to the boiling water, and it evaporates again and condense again, evaporate again and condense again, and this process repeated infinitely until they reach the same speed. That is what we call as vapor liquid equilibrium, VLE. Next, let's move to the next terms called volatility. So, what is volatile? Volatility defined as the tendency to vaporize. It's determined how easily a vapor to turn into liquid. Imagine you are participating in a marathon process. This is same goes for the components in the liquid. They are compete themselves to see which components will be vaporized first, and this tendency is which we call as volatility. Ladies and gentlemen, now I bet you already occupied with the knowledge of the volatility. So, a substance with a lower boiling point, such as alcohol, that tends to vaporize first, it means they have a high volatility. In contrastly, the water has a high boiling point of 100 degrees Celsius that tends to vaporize later, which means there has lower volatility.
Several types of distillation column, so I'm going to talk about flash distillation. So flash distillation is a single stage process. Basically what happens is the liquid mixture will partially evaporate and the vapor and the liquid phases will separate in. Flash distillation is a continuous operation with a steady state condition. So what does that mean is the feed enters the flash distillation continuously and the separation occurs in a single stage, and flash distillation is not time dependent. Moreover, in flash distillation, the separation relies solely on the difference in volatility. No external medium such as steam is introduced.
So, simple distillation is a fundamental separation technique used to purify liquids based on differences in their boiling points. In this method, a liquid mixture is placed in a steel or round bottom flask and heated. As the temperature increases, the component with the lower boiling point vaporizes first. The vapor travels through a condenser where it cools and returns to the liquid state and is collected in a receiving flask. So the process operates in a cycle where the distillation composition changes over time. Initially, the distillation is richer in the more volatile component. As the distillation continues, the remaining liquid in the still becomes enriched in the less volatile components. So let's talk about the steam distillation. So steam distillation is a specialized method for distilling immaculate liquids such as essential oils and water. Steam is introduced into the distillation setup, lowering the boiling points of the mixture. The mixture vaporizes at a temperature lower than the boiling points of the individual components, preserving the integrity of heat sensitivity substance. The vaporized components are then condensed and collected in a receiver. The steam distillation is suitable for separating volatile and heat sensitivity compounds. It highly relies on the combined vapor pressure of immaculate liquids to reduce boiling points. It is often used in industries such as perfumery, pharmaceutical, foods, and flavor extraction.
Did you know that most of the water on Earth is undrinkable because it's salty? Imagine if we can turn the seawater into clean drinking water. And the good news is, we can. The process is called distillation. Here's how it works. Seawater is heated until it becomes steam. The steam leaves behind all the salts and impurities. Then it's cooled and condensed back into liquid form. What's left? Pure clean water. This method is used in desalination plants worldwide to provide drinking waters to millions and millions, especially in the areas with water shortages. It's science solving a real world problem. Distillation shows us how a simple idea can make a big impact. Clean water thanks to distillation.
Okay, so now let's move on to the second real-life application. Distillation plays a critical role in Malaysia's oil refining industry, transforming crude oil into essential products like gasoline, diesel, and jet fuel. Refineries like Petronas in Malacca use advanced distillation columns to separate hydrocarbons according to their boiling point, ensuring high efficiency and quality. This process not only supports domestic energy needs but also drives significant exports, contributing to Malaysia's economy. Distillation's precision highlights its importance in meeting global energy demands sustainably.
Do you guys know that we can make our own distilled water in our houses? Okay, that's what we're going to do now. The process is very easy. All you guys need is a pot, a lid bigger than the pot, and a bowl and some ice cubes. First of all, put the bowl inside the pot and fill the pot with water until the bowl started to float. Okay, next what you guys have to do is take out the bowl and start heating the pot. Okay, and after a while you guys put the bowl inside the pot again and close the pot with the lid and make sure the lid is upside down. Okay, next put the ice cubes on top of the lid. After all the ice cubes have melted and the water is evaporated, it will take roughly 10 minutes. Remove the lid and carefully take out the bowl outside of the pot. Okay, that's it. Your homemade distilled water is ready.
Let's recap back what we have learned in this video. Throughout this video, we have learned the concept of VLE, volatility, and boiling points. Of course, we also exposed to several types of distillation and real-life applications. In a nutshell, distillation is really an amazing process to explore in chemical industries. Are you feel interested? Are you feel anxiety? Are you feel excited? Welcome to join our community. We will bring you to the fantasy of chemical engineering. And if you like this video, don't forget to like it, share it, and comment so it can reach to the more community to understand about the chemical industries. Thank you for watching.